Alright, let's look at day 15. So today's one, still got an hour and a half to do it on time, so let's start my box. We're not going to watch the walkthrough, and then, so today's one, let's copy title, do a title update. Right, so day 15, machine learning again. We're going to do Jingle Bell Spam. The machine learning saves the day. Over the past few weeks, the Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into a trap of clicking on links and providing credentials. Spam emails are somehow ending up in the mailing inbox. It looks like the spam detector in place since before the merger. It was disabled or damaged deliberately. Suspicion is on McGreedy, who is not so happy with the merger. McSkiddy has been tasked with building a spam email detector using machine learning. She's been provided with a sample dataset collected from different data sources to train the machine learning model. In this task, we'll explore different steps in the genetic machine learning pipeline, the machine learning classifications and training models, how to split the dataset into training and testing data, how to prepare the machine learning's model, and how to evaluate the model's effectiveness. So today we don't need the attack box again, and there is a link. No, we don't need a link. We've got the split screen view. So we're going to deploy the machine attached to this task by pressing the green Start Machine button at the top right of the task. After waiting 3 to 5 minutes, Jupyter will open on the right hand side. If you cannot see the machine, press the blue Show Split Screen button. So Jupyter Notebooks, this is again what we did on day 1 or 2, so that's hopefully preparing us for today. So this will provide you with an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning and scientific research. In this room we'll perform the practical on Jupyter Notebook. It's important to recall that we need to run the code from the cells using the Run button or by pressing the shortcut Shift-Enter. Each step is then explained in the notebook for better understanding. Let's dive into the detail. So explore the machine learning pipeline. The machine learning pipeline refers to the series of steps involved in building and deploying an ML model. These steps ensure the data flow efficiently from its raw form to predictions and insights. A typical pipeline will include collecting data from different sources in different forms, reprocessing it, and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning models and predictions. Step 0. We import the required libraries. Before starting with the data extraction, we'll import any required libraries. The notebook comes with all the libraries we need for machine. Here are 2 important key libraries, NumPy and Pandas. These libraries are already explained in the detail in previous task. So let's start our spam email detection in the following steps. Step 1, data collection. This is the process of gathering raw data from the various sources that we're going to be using for machine learning. This data can originate from numerous sources such as databases, text files, APIs, online repositories, sensors, surveys, web scraping, and many others. Here we are using the Pandas library to load the data collected from various sources in the CSV format. The data set contains spam and ham, non-spam. I've never heard of ham before. And then we need to run that. So hold on there until it starts, which it just has. Good timing. So let's run that to make sure that the libraries get pulled in. And then data collection. So let's run new, pull in the data. So now we can review the data set that we've just imported. The following column contains the email classification and a message column which contains the email body. So let's run new. Get it to display nicely. No. Rotation mode? No, that doesn't make any fucking difference. I'm only trying to zoom it out so it looks nice. Right, whatever. Right, data frames provide the structured and tabular representation of data in an intuitive and easy to read format. Using the command below, we can use Pandas library to convert the data into a frame, and then this will make it easy for the data to be analysed and manipulated. So we need to run data frame. It's really annoying that it doesn't all fit. Right, so classification. So we've got a load of potential spam. Spam ham, spam ham, ham, spam. So we get that. So then the data processing. So this refers to the technique used to convert the raw data into a clean, organised, understandable and structured format suitable for machine learning. Given that the raw data is often messy, inconsistent or incomplete, pre-processing is an essential step to ensure that the data feeding into the ML modules is relevant and of high quality. Here are some common techniques in data processing. Cleaning to correct the errors, fill missing values, smooth noise. Normalization, scaling numeric values. Standardization, so rescaling data that you have to mean 0, standard deviation of 1. Feature extraction, so transforming arbitrary data such as text or images into numerical features. Dimensionality reduction, so reducing the number of variables under consideration by obtaining a set of principal variables. Discretization, is that a thing? I've never heard of that before. Transforming continuous variables into discrete ones. Text preprocessing, so tokenization, stemming, lemmatization to convert text into a format usable for ML algorithms. Then imputation, replacing missing values with statistical values to mean median, mode or constant. Feature engineering, so creating new features or modifying existing ones to improve the model performance. And then utilizing count vectorizer. Machine learning models understand numbers and not text. This means that the text needs to be transformed into a numerical format. Count vectorizer is a class provided by the scikit-learn library in Python, and it achieves this by converting text into a token, a word count matrix. It's used to prepare the data for machine learning models and predict decisions on. Here we're using the count vectorizer function from the scikit library. From sklearn feature extraction text import, we need to do this bit. So run new. We'll now use the count vectorizer function to transform the message into column numbers into numeric as shown below. So run that and print. So now we get that. And then step 3, to train, test the split dataset. It's important to test the model's performance of unseen data. By splitting the data, we can train the model on one subset of its test and test its performance on another set. So here the variable x contains the dataset, and we'll use the functions from sklearn's library to split the dataset into training and testing data. So that should be passed here. There we go. So we run u and run u. The first argument to train test split is the feature matrix x, which we obtained from the count vectorizer. This matrix contains the token counts for each message in the dataset. Y is the second argument, contains the labels for each instance in the dataset, which indicates whether the message was spam or ham. And then test size 0.2 is the argument that specifies 20% of the dataset should be kept as the test set and the others should be used for training. It's a common practice to hold out a portion of the dataset for testing to evaluate the performance of the model on unseen data. This is where the actual splitting of data and training set happens. So that has happened already. So yeah, so we can skip that onto there. So model training. So now that we have a dataset ready, the next step is to choose the text classification model to use it on training on the dataset. Some commonly used text classification models are explained below. Naive Bayes classifier, probabilistic classifier based on Bayes' theorem with an assumption of independence between features. It's particularly suited for high-dimensional text data. Support vector machine, so a robust classifier that finds the optimal hyperplane to separate different classes in the future space. Works well with non-linear and high-dimensional data when used with kernel functions. That sounds like... Has anyone ever gone onto this before? Let me grab it. So this is the corporate bullshit generator. It's got a load of words in it, and you can just generate monotonically transform competitive users. We will dynamically foster reliable communities. Like, it literally sounds like that. This will find the optimal hyperplane to separate different classes in the future space. Right, then logistical regression, a statistical model that uses logistical functions to model a binary dependent variable, in this case spam or ham. Decision trees, this uses a tree-like graph decisions where the possible consequences. Simple to understand, you cannot overfit if pruned properly. Random forest, an ensemble of decision trees, typically trained with the bagging method to improve predictive accuracy and control overfitting. Gradient boosting machines, an ensemble of learning method is building strong predictive models in a stage-wide fashion, known for outperforming random forests if tuned correctly. And then K nearest neighbours, the non-parametric method, classifies each data point based on the majority vote of its neighbours, with the data point being assigned to the class most common amongst its K nearest neighbours. Model training using naive Bayes. So naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non-spam emails, determines whether the new email is spam or not. This is how it works. So we'll say that we have a bunch of emails with some labelled as spam and others labelled as ham. The naive Bayes algorithm learns from these emails, looks at which words are in the email and calculates how frequently each word appears in a spam or a ham email. For instance, words like free, win, offer, lottery might appear more in spam emails. The naive Bayes algorithm calculates the probability of email being spam based on the words that it contains. When the model is trained with naive Bayes, it gets the new email that says, for example, win a free toy now. When it thinks win often appears in scam, it then increases the chance of the email being spam. Free is also common in spam, so it increases the spam probability. Toy is neutral, it could appear in either. Then after considering all the words, it calculates the probability of the email being spam and ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies it as spam, otherwise it's classified as a ham. So if we use naive Bayes to train the model, as shown in the and explained below, let's run new. So X is the training data that we want to learn from. This token counts for each message in the dataset obtained from the count vectorizer. Y is the correct label. This is where the actual training of the model happens. The fit method is used to train the model on the training data. When we call the fit method, the multi-nominal NB model goes through the data and learns all the patterns. In the context of naive Bayes, it calculates the probabilities and likelihood of each feature word token being associated with each class. These calculations are based on Bayes' theorem, and the assumption of feature independence is given a class label. Once the model has been trained with the fit method, it can be used to make predictions on new and unseen data. Alright, so last one, almost the last one. After training, it's essential to evaluate the model's performance on the test set and gauge its predictive power. This will give you the metrics such as accuracy, precision, and recall. So let's run that. 98. Not bad. So this classification report function takes the true labels y-test and predicted label y-pred, returns the text report showing the main classification metrics. Precision is the ratio of the correctly predicted positive observations to the total predicted positives. The question it answers is, of all the samples predicted as positive, how many were actually positive? And then recall, the ratio of the correctly predicted positive observations to the actual positives. It answers a question of all the positive samples, how many did we predict correctly? F1 score, this is a harmonic, which means the precision and recall metrics. It gives a better measure of the incorrectly classified cases than the accuracy metric, especially if there's an imbalance between classes. Support is the metric number of actual occurrences of the class of the specified dataset. Accuracy, the ratio of the correctly predicted observation to the total observations. Macro average, this averages the unweighted means per label. And then weighted average, this is the support weighted mean per label. The report gives us an insight into how well the model was performing for each class and overall in terms of the metrics. So testing, so we can here. So testing. Once satisfied with the model's performance, we can use it to classify the new messages and determine if they're spam or ham. Run that. Email is spam. We could have completed one cycle of machine learning, leaving behind deployment. Right, so what next? McSkiddy is happy that the workable spam detector model has been developed. She has provided us with some test emails in the file test-emails.csv and wants us to run the prepared model against these emails to test our model results. So we need to run u. Okay, didn't like that, so I need the file test emails.csv. And run, there we go. So that's the first one. We can see reply of your name, blah blah blah. And then we need to run the vectorizer, get the new prediction and print result. So the expected outputs, the first one was spam, that was all printed, and then all the rest, like ham, spam, ham. So then this is from the task, so this is it for the task. Once the practical point of view, we've considered the following points to ensure effectiveness and reliability of the model. Continuously monitor the model's performance on a test dataset in a real-world environment. Collect feedback from the end users regarding false positives. Use the feedback to understand the model's weaknesses and areas of improvement, and then deploy the model into production. So what was the key first step in the machine learning pipeline? Is it data collection or cleansing? There we go. What data pre-processing feature is used to create new features or modifying existing ones? That was... No, it's gone from my brain. It's feature creation or something like that, isn't it? Feature engineering. Okay. During the data splitting step, 20% of the dataset was split for testing. What is the percentage weightage average of the precision of spam detection? So we need the result. Percentage weighted average of precision was 0.98. Hint was, if your answer is not accepted, it could be due to the results in ML varying slightly. Okay. How many of the test emails were marked as spam? 3. One of the emails detected as spam contains a secret code. What was the code? So it's not going to give it to me like that. So maybe it's in... Just look at it. Secret code is I hate best festival. And if you enjoyed this room, please check out the fishing module, which we've done already. So we've done those. And that's it for day 15. That was cool. Really nice to see some machine learning in there, because that's something that we're all going to have to learn at some point. It's unavoidable at this point.